Hello and welcome to this video in which I will show you how you can obtain Mardia's test of multivariate normality for a confirmatory factor or structural equation model in Mplus. My name is Geiser. I'm an instructor and statistical consultant with QuantFish, and on this channel I present weekly statistics tutorials. On Tuesdays I usually discuss an analysis in the Mplus software, and on Thursdays I talk about more general issues in multivariate statistical analysis, including structural equation modeling, factor analysis, multi-level analysis, and latent class modeling. If this is something that interests you, then please subscribe to this channel. Also, don't forget to hit the like button and to check out the description for additional resources, including a link to my free weekly statistics newsletter as well as courses that I teach for QuantFish. In this video, I want to show you how you can obtain Mardia's test of multivariate normality when running a confirmatory factor analysis or structural equation model in Mplus. This is something that is not obvious in Mplus because there's not a standard option for a conventional structural equation or factor model that is run through the analysis option type equals general. Instead, you have to go on a little detour into the world of mixture modeling in Mplus to obtain this test. And the reason for that is probably that the Mplus folks think that tests of multivariate normality are pretty much outdated and not really needed anymore. And that's because there are so many possibilities now to deal adequately with non-normal data in structural equation modeling and factor analysis. There are robust estimation methods such as the Satora-Bendler correction. There are robust estimators that are specific to Mplus, such as, for example, MLR or MLMV that you can use and that provide you with adjusted standard errors, adjusted tests of model fit, an adjusted chi-square test, and also adjusted test statistics for the parameter estimates, which are based on those robust standard errors. And so therefore the Mplus folks kind of think that this isn't something that you really need, so it's not a standard option for SEM and CFA. However, it is implemented in Mplus for mixture models, and so you can basically trick Mplus into running Mardia's test by going through a mixture analysis. So in other words, if you really want it, maybe a reviewer asks you to report this test in a paper, and you think, okay, I want to please this reviewer, I don't really care about the test, but the reviewer really wants it, and so how can I get it? And so then the way to do this is to actually specify a factor or structural equation model as a mixture model in Mplus. And so why is that? What does this have to do with mixture models? Mixture models are latent class models where we assume that there's population heterogeneity such that a different factor model might hold in different latent classes. So for example, there might be classes that differ in their growth pattern over time, and then with a growth mixture model we can separate classes that show distinct growth or change trajectories across time. There are also other factor mixture models that allow us to look at hidden groups that may show different parameter estimates. And so Mplus has the Mardia's test for skewness and kurtosis implemented for mixture models because it's a test of whether the mixture model with multiple latent classes adequately captures the non-normality in the data. When we have mixture distributions, then that results in non-normal distributions, and then the question is whether a mixture model can adequately reflect that. And so it's used in that way in Mplus to test a mixture model, basically the fit of a mixture model. But we can also use it to get the conventional test of multivariate normality for a standard factor or structural equation model with a single class, in that we can specify, okay, we can run any kind of conventional CFA or SEM model in Mplus as a single class model. So by specifying type mixture but estimating only a single class, we get the same parameter estimates that we would get if we used analysis type general without the mixture option. So that's how you do it. So say you trick Mplus by specifying the model as a single class mixture model, which then it's not really a mixture model. and then you get the test that you want. So let's take a look at the Mplus syntax for that. Here you can see that in my data set I have 4 variables. I'm specifying a simple 2-factor model. Each factor has 2 indicators in this model, and I'm adding this command here that usually you wouldn't need in Mplus for a standard factor model with a single group or class. The classes subcommand, which specifies that there is a latent class variable C with just one latent class. So it's a single class model, and that's the same thing as, so say, not having a latent class variable. And so that tricks Mplus into giving you this test in conjunction with this command analysis type equals mixture. So normally you would specify type equals general for a CFA model or for a structural equation model in Mplus, or you would specify nothing at all for analysis because type equals general is the default in Mplus, and so you would get a normal analysis. But when we use mixture modeling, then we have to put in this analysis type equals mixture, and then this will be a latent class model or a factor mixture model or a latent profile model or a latent transition analysis, depending on whatever else we specify in our model statement. In this case, it is a factor model with 2 factors. Each factor has 2 indicators. So factor F1 has Y1 and Y2 as indicators. Factor F2 has indicators Y3 and Y4 as observed variables. And in this case, so say this looks exactly like what we would specify in a standard factor analysis, confirmatory factor analysis specification in Mplus, but we have to add the overall subcommand here because this is a mixture model. And so when you use type equals mixture, you have to have this overall statement in Mplus, but it doesn't mean anything really here because there's only one class. And then the last thing that you need to include is the output option tag 13. So technical output 13 is what gives you this Mardia's test of skewness and kurtosis. And so then when you run your syntax like this, then you get this test. So let's take a look at it. This is already output. The output here for this syntax example, we have 500 cases. This is a simulated data set, and to make it easier to show this, and so let's scroll down. When you scroll all the way down, you get your normal parameter estimates. Here it says latent class 1, but there is only one class, and so therefore it's the same. You get the same parameters and standard errors that you would get for a standard confirmatory factor analysis with type equals general. And then when we scroll down further, you can find the tag 13 output, where you find the skew and kurtosis tests. First is a 2-sided multivariate skew test, and you can see here that the p-value for this test is not significant. So p is 0.23, which means that the model of normality is not rejected here. So the data are of skewness, so the data are not significantly skewed in terms of multivariate skew. And the same is true for the 2-sided test of multivariate kurtosis, which comes below that, and the p-value here is 0.3, so at an alpha level of 0.05, also again this model of normality would not be rejected. So this would indicate that multivariate normality here is not violated, which makes sense because I simulated the data according to a multivariate normal distribution to illustrate, so say what this would look like if multivariate normality were not violated. Mplus also includes univariate and bivariate tests of skew and kurtosis. So first then is the univariate skew and kurtosis tests that are given here for all 4 variables, and then we have, this is for skewness here first, and then kurtosis, and then also we get bivariate skew and kurtosis tests in Mplus for each pair of variables, again starting with the skewness tests right here for all these pairs, and then the kurtosis test. So it's very comprehensive. The question is, do you need it? And once again, most experts in CFA and SEM would probably agree that these tests aren't really super useful, other than maybe satisfying a reviewer who wants to see those tests, because even if we had a significant result here indicating significant departures from multivariate normality, and we wanted to use maximum likelihood estimation still, which requires multivariate normality or has that as an assumption, we would still not be in very big trouble, because we have robust estimators that can handle non-normal data really well. We have the Satora-Bentler correction, which is the analysis type or estimator type MLM in Mplus. We also have a robust estimator MLR in Mplus that you can use even when you have missing data. So that's often the estimator of choice in Mplus with missing data and non-normality. We have MLMV, and we have other estimators that we might also use for non-normal data. So we're not really in trouble if we find that multivariate normality is violated. We should then just pick a robust estimation method, because primarily what is affected are the standard errors and test statistics, and those can be corrected, for example, with MLR or MLM in Mplus, and so therefore it's not a big problem. I also have additional videos on how to deal with multivariate non-normality on this channel, so check those out as well. In summary, it's really not the biggest concern anymore nowadays, because we have these robust estimation methods that yield adjusted standard errors and adjusted tests of model fit, so that we don't have to worry too much about multivariate non-normality. Nonetheless, you might want this Mardia's test for whatever reason. Again, maybe a reviewer needs to see this, or you want to show it in class maybe to your students. So here it is. I hope you found this video useful. If you did, please hit the like button, subscribe to this channel, and don't forget to check out the description for additional videos and workshops, and I'll see you next time.